Hi everybody and welcome. Today's video we're going to be looking through two different types of skills. So the first skill is evaluating equations, and the second skill is checking systems of equations. These two things go hand in hand pretty closely. Basically the big concept for today that's going to link both of these together is the idea of balance, of having each side, the left and the right side of an equation, equal each other. So that is our goal for today's learning. After watching this video, hopefully you should be able to successfully plug into an equation and check for balance, and also plug into a system of equations and check for balance there. So first things first, system of equations. And this is a set of equations. So multiple equations, could be many of them, there's no limit to it, for which common solutions exist. So common solutions means that both equations have the same solution. So that's kind of the idea here of what we're looking at. Really, really important when we are looking at systems of equations, a common solution is the same thing as a point of intersection. So what that means on a graph is that if we have two different equations, a common solution is a point of intersection, is where they come together. At this green point, the x and the y value for both equations is the same, so that is a solution to a system of equations. A second thing to note when we are talking about equations is that we are balanced. So if you were to draw a scale on the side here, and there is think about it as like you're balancing a pen on your finger, and if you move it a little left or a little right, one side is heavier and it falls off, but if you get it perfectly centered, there's equal weight on both sides. That's exactly what we're looking at here. So an equation means it's equal, both sides have that nice balanced pen, equal weight on both sides. So when we're plugging in these solutions to check if they are in fact balanced, we're going to replace each variable. So I'll just write down x with the term provided. So they tell you x equals 5, take x out, put 5 in its place. 5 and x are balanced, they weigh the same, so we're allowed to interchange them. Second, we're going to use the order of operations. I'll just write PEMDAS for shorthand. To evaluate, so once you have plugged in that number or term for x, all you're going to do is just start solving one step at a time with the goal of getting an answer that is a number. Last, we are going to check that each side of our equal sign has basically equal terms. And I'll put in parentheses here, balance. So what we're going to see is if we have something like 5 equals 5, that's balanced. But if we had something like 4 equals 5, we know that 4 does not equal 5, so that would be not a solution. So not a solution means unbalanced, solution means balanced. So for our first example here, let's go through the steps. I'll show you an example. Is x equals 3 a solution to 12x minus 6 equals 9x? So is x equals 3 a solution to 12x? So wherever we see the x term, we're going to replace it with the 3 because 3 and x are the same thing. So we have 12. Instead of x, we're going to write 3 in its place. And from there, we're copying everything directly just straight down. So now it's time to use PEMDAS, and I just realized I have another x. So I made a mistake. I should have replaced all of my x's. So all of the x's have to be replaced with a 3. Okay, so now we're ready. Now that we just have numbers and all the variables are gone, we can draw our algebra line and start evaluating using PEMDAS. So parentheses, nothing inside of parentheses other than a single number. I don't see any exponents, but we do see some multiplication. So 12 times 3 is 36. More multiplication here, 9 times 3 is 27. On the left side, the only step left is subtraction. So we have 30 on the left and 27 on the right. So if we're thinking about our balance, we have 30 on one side and 27 on the other side. So this is not balanced. So this is not a solution. So that would be the answer that we're looking for. We're not trying to get like x equals 3. We're not trying to solve this. We're just asking and answering, is it or is it not a solution? So in this case, no, it is not a solution. So I'm going to let you try number 2 now. Which ordered pair is a solution? Be careful. Maybe multiple of them are solutions, so you want to make sure you're testing each one. And they also have to be solutions for both. So go ahead and answer this now. Which one of these ordered pairs or multiple ordered pairs is a solution to both equations listed below? So what we want to do is just one at a time here. We have x and we have y. So everywhere that there's an x, we'll put in a 2. Everywhere that there's a y, we'll put in a 3. So plugging into our first equation here with our first term, we'll get 5 equals 1. So that is not a solution. So if it fails one of them, we know it basically it doesn't work for both. So because it doesn't work for both, we say not a solution. Okay, our next one, we can plug in 4 and negative 3 into, well, just go into our first one. So x is 4, y is negative 3. So 4 minus 3 is 1. Okay, so that works. We have to make sure it works for both equations. So we'll plug into our next one now. So 2 times 4 minus y is negative 3 equals 11. So that's 8 minus negative 3 ends up being plus 3. So that actually is true. So this one is a solution. But of course, we are not done. We still have to test our last one here. So 1 comma 1, so 1 comma 1. And we know that 2 does not equal 1, so not a solution. So again, just practicing plugging in. Anywhere that you have an x, replace it with the x value. Anywhere you have a y, replace it with your y value. And you should be good to go from there. So second one here, again, where is it a solution? All right, on the bottom, we're going back to the definition of what is a solution to a system of equations. So we just saw it above using algebra. So a system of equations has a solution where a value makes both equations true. So on the bottom here, we're going to take a look at what is a value that makes both these equations true. Well, if you remember from up top, it's where they intersect. We write answers to these. You have two options. You can write x equals and y equals next to each other, or you can write an xy ordered pair. Just be careful with your xy ordered pair. X is your left, right, so positive is right, negative is left. And y is up and down, so positive is up, negative is down. So here, where we intersect from the origin, we go 2 to the right, so x is 2. We go up by 2, so y is also 2. So you can also write it here as x equals 2 and y equals 2. So I'm going to ask you to do the same thing for the second one here. Tell us xy ordered pair, x comma y. Where do these two lines intersect? What is our solution to this system? So go ahead and answer that now. All right, and what you should see here is from the origin, we go 1 to the right, that's positive 1, and be careful, we go 3 down. So because we go down, it's going to be negative 3. So x equals 1, y equals negative 3. So major skills for today that we're going to be looking at and practicing is basically plugging in. So plugging in for x, plugging in for y. The second thing is after we have plugged in, we want to check and make sure that the left side equals the right side. So as long as you follow the steps of order of operations, you do it one step at a time, you should be in a place to be successful for today. So as always, if you got questions, go ahead and ask. Thanks for watching, and you can get started on the practice.